My dear students, in this video we are going to discuss horse questions. These are little tough questions, but if you solve all these questions, it means you are being perfect in this chapter. So under this video, the very first question is this one. Find the remainder when this is divided by x plus 1. Means I am gonna use remainder theorem here. And how do you find the remainder? Put x plus 1 equal to 0. X is minus 1. Now how do we find the remainder? Replace x by minus 1. Minus 1 powered 101. This is odd number, so minus 1. This whole value will be negative 1. 101. So the answer is 100. Next is, just go through the question first. If x powered 100 plus 2x powered 99 plus k is divisible by x plus 1, then find the value of k. Means this is, it should be here exactly divisible. Means a remainder is 0. And how do you find the remainder? By remainder theorem. X is minus 1. I assume f of x is x powered 100 plus 2x is powered 99 plus k. So replace x by minus 1. I will be getting the remainder. 2 times minus 1 power 99 plus k. This is the remainder. But as per the question, remainder is 0. Why? Because this whole polynomial is exactly divisible by x plus 1. Minus 1 power even 1 plus this is negative 1. So negative 2 plus k equal to 0. Minus 1 positive k equal to 0 means k is 1. And the value of a for which this is a factor of f of x. Same kind of concept. X minus a is a factor. It means a remainder will be 0. You can use remainder theorem here or factor theorem. Meaning is same, answer must come. That's it. So how do you find the remainder? Put equal to 0 and x is what? A here. F of a. That will give me the remainder. But remainder is, in this case, is 0. Why? Because this value is a factor of this. So how to find the remainder? A power 5 minus a square into a cube plus 2a plus a minus 3. That is the remainder. But remainder is 0. This is a powered 5 minus a powered 5 plus 2a plus a 3a negative 3 equal to 0. Both signs are different, so get cancelled. This is 3 equal to 3. The value of a is 1. If x over y plus y over x equal to minus 1, find the value of x cube minus y cube. X cube minus y cube, this is the identity, and that is equal to x minus y, x squared plus x times y plus y squared. So let's see how does it help us to find our answer. The LCM is xy. Here I will be getting x square plus y square equal to minus 1. Cross multiply 1 with the x square plus y square. Take this up on right hand side, so I will be getting minus xy. Take this on this side. So x square plus y square positive xy equal to 0. This value is 0. X minus y, this value is 0. So answer is 0. That's it. If x plus 2 and x minus 1 are the factor of this, find the value of m and n. So use factor theorem or remainder theorem. That's up to you. This is equal to 0, so x is coming 1. In both the cases, remainder is coming 0. So first I assume f of x equal to x cube plus 10 times x square plus mx plus n. I find f of minus 2. Because this is a factor of that, so remainder will be 0. Okay, minus 2 3 times, minus 2 cube, no? Minus 2 cube is what? Minus 8. Minus 2 square plus 4 times 10, so minus 2m. Minus 2m plus n. That is the remainder. But the remainder is equal to 0. Simplify. 32 minus 2 times m plus n equal to 0 means minus 2m plus n equal to minus 32. Come on the second part. Here x is 1. If x is 1, f of 1, that will also be 0. So replace x by 1. 1 cube plus 10 plus m plus n equal to 0. Equal to 0. But we have 11 plus m plus n equal to 0 means m plus n equal to minus 1, and what we have already found, that is minus 2 times m plus n equal to minus 32. Just subtract this left hand side from that side, so sign gets changed. Mine m plus 2m is 3m, n minus n, that got cancelled, plus 32 minus 11 is, sorry, what is that? That is 121. So m is coming 7 here. If m is 7, put this value here in this or in that, whatever. Okay, this is 7. 7 times minus 2, minus 14, minus 14 on that side. So n is minus 32 plus 14. The value of n is coming, this is 8 and that is 18. Okay, minus 18. That's it. If 49 times x square minus b equal to this into that factor, then find the value of b here. So this is a little easier one. Left hand side, 49x square minus b equal to a plus b, a minus b. There was one identity, a plus b times a minus b is equal to a squared minus b squared. So 7x squared minus half squared, I will be getting 49x square minus 1 by 4. Now compare the like terms. This equal to that, fine. Minus minus, correct. So what is b? B is nothing but 1/4. My answer. Factorize. There are a number of parts. Let's do every part one by one. First of all, I take a. The first part a. Under root x square plus 3x plus root 2. You know the general form, everything. What should be sum here? Sum should be 3b. Okay. And what should be product? Product should be a times c, means 2 only. So two numbers are, sum should be 3, product should be 2. So two numbers are 2 and 1. That's it. Root 2 x square plus 3x plus under root 2 equal to, now split the middle term. 3x can be written as 2x plus x plus under root 2. Now how to take the common things? That's the important thing here. What is common here and here? You know, this 2 can be written as under root 2 times under root 2. Yes, so what is common? Under root 2 is here and here as well. X is also here and here. So the common is under root 2x. What is remaining here? X plus under root 2. Now what is common here? Nothing, means 1 only. So the two factor are, what is common here and here? X plus root 2, sorry, under root 2, and what is remaining? Root 2x plus 1. So this whole is equal to this value times that. My answer. Part second. Second part is 7 root 2 x square minus 10 times x minus 4 times root 2. Sum should be b. B is what? Minus 10. And what should be product? A times c. 7 root 2 times minus 4. That will be minus 56. Now think of two such numbers whose sum should be minus 10 and product should be minus 56. The two numbers are minus 14 and 4 because sum of these two is minus 10. The product of these two is minus 56. So this whole will be equal to 7 root 2 x square minus 14x plus 4x and minus 4 root 2 as this. Okay, I'm writing this over here. So 7 root 2 x square minus, this is 14. 14 further can be written as 7 times root 2 times root 2x plus, this is 4x. Okay, right, as it is 4x minus, what was this value? This was 4 times root 2. Now what is common here and here? Common is 7 root 2 x. What is the remaining here? X only minus 7 root 2 is taken, the remaining part is under root 2, and here is common positive 4, the remaining part is this. Again, what is common in this whole thing and in this whole thing? That is x minus under root 2. The remaining thing over here is this plus 4. So that's factorization. Sorry. Now third part, that I'm not gonna solve. Let's see part D, because C and B both are same. D part here. In D part, I will assume 3x plus y equal to something else. I'm assuming z. So what I'll get here? 5 times z square plus 6 times z minus 8. I'm to factorize this. This is in z. That's it. So it's still in quadratic polynomial. What should be sum here? Sum should be 6. What should be product? That should be minus 40. Now tell me of two such number whose sum should be 6 and product should be minus 40. The two numbers are plus 10 and minus 4. Correct. So what we have? 5z square plus 6z minus 8 equal to 5z square. 6z can be written in these two numbers, 10z minus 4z minus 8 as it is. Common is 5z, z plus 2 minus 4 common, z plus 2. So we have two factor, z plus 2 and 5z minus 4. This is not my final answer. Why? Because z was assumed something else. Now replace this value back in the answer. So what is z here? 3x plus y plus 2, the first factor, 5 times z. What is z? 3x plus y minus 4. So you can keep this part as it is, or you can take it inside. That's up to you. My answer. These two are the factors first, and this is second. Part F. No. Before that, part E is also pending. In part E, uh, this 2a square can be written as under root a whole square plus, okay, just skip this for a while, come over here. This is root 3b whole square. Now tell me, don't see here, tell me, a square, there is one identity, and the identity was this one, a square plus 2 times ab plus b square, that is equal to a plus b whole square. A square plus b square plus 2 times a times b. Tell me, is this value this value? Yes, correct. Now this whole thing can be written as, using this identity, a plus b whole square. What is b here? Root 3b whole square under root. Means this under part, this one, this is written in this way first, and then this is a perfect square of this value. Now square and under root get cancelled. The answer is under root a plus under root 3b. That's the final answer. Part F. In this part F, x power 4. Now in part F, we have x power 4 minus 3x square plus 2. In this one, I can rewrite this x power 4 as x squared squared minus 3x squared plus 2. Now I assume x square as y. I assume this. So I will be getting y square minus 3y plus 2. This is of question number 5 kind. Now factorize this. Sum should be minus 3 and product should be, sum should be minus 3. The product should be a times c, means 2 only. So the two numbers are negative 2 and negative 1. This value is y square minus 2y minus y plus 2. What is the common part here? Y is common, so y minus 2, here is minus common. So the two factors are y minus 2 and y minus 1. But what is y? Y is x square. Correct. So write it properly. X square minus 2 and x square minus 1. Can you factorize this further? Yes, we can factorize because this further can be written as under root 2 whole square. This can be factorized further. You can, or you can leave it as it is. That's up to you. Okay, if we factorize this, this will be x minus under root 2, x plus under root 2. And here is x plus 1. X plus 1 and x minus 1. I use the identity, which one? A square minus, it can be written as under 2 square. Now we are going to take next part, that is part G here. In G part, what we have, 5a minus 7b whole cube plus 9c minus 5b whole cube plus 7b minus 9c whole cube. This is of this kind of identity if a plus b plus c equal to 0. So let's prove this first. I assume this whole thing is a, this is b, this is c. So a is 5a minus 7b plus, what is b here? 9c minus 5b. And what is c here? C is 7b minus 9c. Something went wrong in the question, I guess. 5c, this was 9c minus 5a. This is a. Alright. And this is correct. So this is 5a. Now 5a got cancelled, 9c got cancelled, this got cancelled. So what I proved? I proved a plus b plus c equal to 0. It means their cube will be equal to 3 times ABC. It means this whole will be equal to 3 times this first one, then times this whole thing, and then this third one. Means the final answer will be equal to this whole thing right here first is equal to 3 times A times B then times C. That is the final answer. Let's move to the next one, part H, that is a power 7 minus ab power 6. I am to factorize this. What is common here? A is common. What is left behind? A power 6, b power 6. Now there are two ways to solve this question. You can choose any. Let's go like this way. What we have till now? We have a power 6 minus b power 6. So I'm writing this as a. You can write this a power 6 as a square then cube. Okay, a cube then square minus b cube then square. A times, now a square minus b square, that will be a plus b, a minus b. Factorize this further. A cube plus b cube is what? A plus b. A square minus ab plus b square. Same here. The identity a minus b. A square plus ab plus b square. This is b square. So the final answer is a plus b, a square minus ab plus b square, a minus b, a square plus ab plus b square. That's it, my answer. You can rearrange the terms. This is a plus b. This I'm writing first here, a minus b, then a square minus ab plus b square, then the final one is a square plus ab plus b square. This is the answer. The last one is can I okay, first write the question. This is a cube b minus c whole cube plus b cube c minus a cube plus c cube a minus b whole cube. Take this a inside, so I will be getting ab minus ac whole cube. Take b inside, so bc minus ba whole cube. Take c inside, so c minus cb whole cube. Is it possible? Yes. If I take a common, a cube will come out. Same here. If I take b common from here, b become b cube. Same with that. Now, why I'm doing so? Because if I assume the whole thing is a, this whole thing is suppose a, correct? Assume this is b and assume this is c here. Then sum of all these three will be equal to 0. How? This will get cancelled, this will get cancelled, this will get cancelled. So if a plus b plus c equal to 0, then a cube plus b cube plus c cube will be equal to 3 times a times b times c here. Now what is common in this one? A is common. The pending part is b minus c. What is common from here? Here is b common. The pending part is c minus a. And what is common here? The common is c here. What is left? A minus b. So the final answer I am writing here 3 times abc. Here is b minus c, c minus a times a minus b. That's the final answer. That is called factorization because this whole thing equal to 3 times abc, b minus c, c minus a and a minus b. Let's come on the next question. Find product of all these four factors of four expression, by the way. So I'm choosing first two. Which identity I'm gonna use here? A plus b, a minus b, that is equal to a square minus b square. So a square minus 1 upon a square. These two become this one. Write the pending one as this: a square plus 1 upon a square, then a power 4, like this. Now this value is a square minus 1 square is 1. Write this as this. The pending part is written as this. Again, assume this is a minus b multiplied with a plus b. So if I use the same identity, this one, I will be getting a power 4 minus, like this. I did it in short. I skip 2 steps here. Then equal to, now this is again a minus b multiplied with a plus b. So again using that identity, I will be getting a4 whole squared minus 1 over a4 whole squared. So the answer I'm going to get here, this is a power 8 minus 1 over a8, a power 8. That's my final answer. Let's see how we did solve this question. First of all, these two expression, if I multiply them, that become this one. How? Because I use the identity here. Then I use the identity, I got this value. Again I use the same identity, I'll get that one, my answer. I am to find the product, correct? Next one. If f of x is this, find f2 minus f1. Okay, let's find it. So how to find f2? Replace x by 2 here. So I will be getting 2 square minus 5 times 2 plus 1 minus f of minus 1. Replace x by minus 1 here. So minus 1 square, 5 times minus 1 plus 1 plus 1 by 3. So 1 by 3 whole square, 1 by 3 whole square minus 5 times 1 by 3 plus 1. This value is 4 minus 10 plus 1 minus. Simplify this: minus 1 whole square 1 plus 5 plus 1 plus 1 over 9 minus 5 over 3 plus 1. Simplify again. This is 5 minus 10. This value I'm solving here. Minus 5. This value is 7 plus 1 over 9 minus 5 over 3 plus 1. Now this value become minus 12 plus 1 minus 11. plus 1 over 9 negative 5 by 3. Take LCM here. 9 minus 99 plus 1 minus 15. Just simplify. This value, okay, first solve these two values. So what I'll be getting here, minus 99 minus 15. So I will be getting 114, I guess. Then negative 113 divided by 9. The answer. Find y square plus 1 over y square and y power 4 plus 1 power by y power 4 if y minus 1 over y equal to 9. We are given this value. So there are two questions. Let's find one by one. Squaring on both sides. What I'm writing here, squaring on both sides. What will happen here? That becomes squared here as well. Now use the identity. Which one? A minus b whole squared equal to a square minus 2 times ab plus b squared. So y squared minus 2 times a times b plus b square equal to 81. That got cancelled. Take negative on that side. So I will be getting y square plus 1 by y square equal to 83. Why so? Because if I take this negative 2 on that side, that become positive. Clear? Next value, again squaring on both sides. So y square, this value is done, I think, my first answer. Now how to find the second one? Again squaring on both sides. So 1 over y square whole square, 83 whole square, a plus b whole square. Now what is a plus b whole square? A plus b whole square equal to a square plus 2 times ab plus b square. So that become y power 4 plus 2 times a square, a times b, the formula, plus square equal to 83 square. 83 square will be, I guess, 6889. 83 square. Okay, fine. Now that got cancelled. We have plus 2 here. Take this value on that side. That become negative. So y power 4, 1 by power 4. This plus 2 become negative 2. So the answer is 6887. The final answer. One answer is over here and the second answer is here. Next question we have. If a, b and c are the known zeros and a plus b plus c equal to 0, then prove that this value should be equal to 3. Okay, this identity, I think you remember. If this happens, a cube plus b cube plus c cube equal to 3 times abc. Now how to prove this left hand side equal to 3? You can go in many ways. Answer will come same. Now this is given to us, so I'm gonna take LCM here, or you can do one more thing here. Multiply this by a and divide by a. I will be getting a cube a times bc. Same here, multiply this by b and divide by b. I will be getting b cube abc. Same with that, multiply and divide by c. So I will be getting this value. Now take LCM. The LCM is ABC. I will be getting here a cube plus b cube plus c cube. Now this value is already given here in this question. So 3 times ABC divided by ABC equal to 3. This get cancelled, hence proved. You can write this portion here because this happens, that's why we change this by that. The next one we have if x plus y plus z equal to 1 and y plus yz plus zx equal to minus 1 and x times y times z equal to minus 1, find the value of x cube plus y cube plus z cube. So my dear, let's see how to find this value. uh, the basic requirement is what? Okay, let's start from here. uh, X cube plus y cube plus z cube I want to find, and that value can be found from where? We have one identity, x cube plus y cube plus z cube minus 3 times xyz equal to what? That is equal to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. To get my answer, I need this identity. So let's see how to find it. X cube plus y cube plus z cube minus. This value is already in the question, that is minus 1. So minus 1 minus 3, that become positive 3. This value is also in the question here, that is 1. This value is x square plus y square plus z square minus. I took minus common from these three. This is xy yz plus zx and the whole bracket is closed. Just simplify in the next line. Equal to 1 times the whole thing as it is. So we have x square plus y square plus z square minus. This value is again in the question. This whole value. This is minus 1. This is minus 1. X cube plus y cube plus z cube plus 3 equal to x square plus y square plus z square. This value is plus 1. Now to get my answer, I need to find this value. So from where I can find this value? I assume this is 1, correct? Now I have to use this identity, x plus y plus z whole square equal to x square plus y square plus z square plus 2 times xy plus 2 times yz plus 2 times zx. This value is in the question, that is 1. This value I want to find, and what is common in all these? 2 is common. The remaining part is x times y, yz and zx. This value is again in the question, that is minus 1. Now minus 1 times 2, minus 2. So this whole part become minus 2. Take this whole minus 2 on that side. So that become plus 2. So the value of x square plus y square plus z square is nothing but 3. This value is nothing but 3. Now replace this value in 1. From 1. I am writing here now from 1. Put this value here in 1. What we have? X cube plus y cube plus z cube plus 3 equal to x square plus y square plus z square equal to 3. 3 plus 1. This got cancelled. So the final answer is 1 only. X cube plus y cube plus z cube is nothing but 1. The answer. The next question is, without actual division, prove that this polynomial is exactly divisible by x square plus 2x minus 3. Now one way is the direct way. What is the direct way? Just divide this whole polynomial 2x cube minus 2x square minus 3 by this polynomial x square minus positive 2x minus 3. and just use the long division method and you will get a remainder 0. It means this is a factor of that, or it means this is exactly divisible by this if I prove remainder is coming 0. And what is the method? That long division method. But as per the question, this is given to us without actual division. Now without doing this long division, I am to prove this is a factor, or this whole polynomial is exactly divisible by this polynomial. So what is the method for this? Let's see here. In this method, I have to find the factor of the given divisor. So how do you factorize this? It's a quadratic polynomial. Sum should be positive 2. Sum should be positive 2, and what should be the product? A times C means 1 times minus 3, negative 3 here. Now tell me two such number whose sum should be positive 2 and product should be negative 3. So the numbers are positive 3 and minus 1. Sum of these two numbers is positive 2 and product of these two is negative 3. So how do you factorize the polynomial this? Just split the middle term in the form of these two numbers. So x square plus 3x negative x negative 3. What is common in the first two? Only x is common. Again, what is common from here? 1 is common, negative 1. The pending part is this. I have two factor x plus 3 and x minus 1. Now, because I want to prove this is exactly divisible by this, it means I have to prove uh, x square plus 2x minus 3 is dividing this given polynomial exactly. So what is the method? From here I have to find, because this is a factor of the polynomial, I want to prove that, it means this will also be the factor of this. What is the question? What I want to prove? I want to prove this is dividing this polynomial exactly. It means its factors. What are the factors of this? These two. Means x plus 3 and x minus 1. These two will also divide this whole polynomial exactly. It means these two are the factor of this. And if these two are the factor of this, I can easily find the remainder of this. So what is the method? Find the value of x from here and find the value of x from here. 1. Now if I prove this polynomial is becoming 0 on this value, then this is a factor of this. Same, this is a factor of that. So what is the method? First assume p of x, the given polynomial, x powered 4 plus 2x whole cube minus 2x squared plus 2x negative 3. Just replace x by negative 3. Negative 3 powered 4, I guess 81, plus this is negative 3 3 times, minus 27 times 2 minus 54. This is here is 9 times 2 minus 18. This is x minus 3 times 2 minus 6 minus 3 again. Just simplify. 81 minus 54 minus 18 minus 6 and minus 3. 54 plus here is 18, so 60 72 72 and 9 81. So this is negative and this is positive, means 81, this is minus 81, so this is 0. It means x plus 3 is a factor of p of x. Similarly, find the value of p of 1. Let's find it. Replace x by 1. This is 1, this is 2, 1 plus 2 minus 2 plus 2 minus 3. This got cancelled. This is 3, this is negative 3. Again it is coming 0. It means x minus 1 is a factor of p of x. Now because x plus 3 and x minus 1 both are the factor of px, it means their product. What is their product? x plus 3, x minus 1 is also a factor of p of x. And what is this product? This product is nothing but this polynomial. What is that? X square plus 2x minus 3 is also a factor of p of x. Now, what is the meaning of this is a factor of this? It means p of x is exactly divisible by x square plus 2x minus 3. Hence proved. So let me repeat the whole thing again. I want to prove this is exactly divisible by this polynomial. One way, the long division way, that we are not supposed to take because this is given without actual division. That's why we are not going to take that method. Second method, find the factors of this, and I found it, x plus 3 and x minus 1. Correct? If this is exactly divisible by this polynomial, it has to be divisible exactly by its factor as well. And I prove it by factor theorem here. Correct? That's it. The next question is simplify x plus y plus z whole squared minus x plus y minus z whole square. So that's very simple question. Maybe it will be taking hardly 2 or 3 lines. There is one identity we have learned. A square minus b square is nothing but a plus b, a minus b. So I assume this is a. Okay, first write the question here. The question is x plus y plus z whole square minus x plus y minus z whole square. So I assume this is a. A square minus b square is equal to a. This is a plus b. B is this value. A plus b is done. A plus b. Same. This is a minus x plus y minus z. Now simplify this. This is x plus y plus z plus sign. No change in sign, so write as it is x plus y minus z. Next one, x plus y plus z minus, because this is an active sign, so all sign get changed. Minus x minus y plus z. Now simplify. Here z get cancelled, here x y get cancelled. So we have 2x plus 2 times y. Here we have 2 times z. What is common from here, from this factor? 2 is common, so take 2 out. This 2 and this 2z, that become 4z. What is left behind? X plus y. So how to simplify this? Simplify this means this whole thing is equal to 4 times z times x plus y. That's it. Basically I use one identity here, a square minus b square. Show that 2 times a square plus b square is equal to a plus b whole square. What was the question? Show that if this is there, I am to prove a equal to b. Let's see how to prove it. The given part is a square plus b square is equal to whole square of a plus b. So just to take 2 inside, 2a square plus 2 times b square. Open the identity, I will be getting a square plus b square plus 2 times ab. There can be more ways to solve this question. That's my way. I am taking this. There are many more ways. Now what is the next method? Take these 3 terms on the left hand side. So 2a square minus a square, only a square. 2 times b square minus b square, 1 time b square. This is plus 2ab, take this on that side. So minus 2ab equal to 0. That is the identity of what? Of a minus b whole square equal to 0. If I take square root both sides, you can write here if you want, taking square root on both sides, or just simply you can do one thing, square root of this side and square root of this side. That got cancelled. We have a minus b under root 0, 0 only. Take this minus b on that side. Hence proved. Next question is comprised of three different parts, and these three parts, the very first part is x square plus 2 times ax minus b squared minus 2 times ab. Again, I am repeating, my dear, there can be another way to solve this question to factorize this. What I'm going to do, I'm combining these two and these two separately. How? X square negative b square. Write the pending terms as this: 2 times ax minus 2 times ab. Let's see what will happen if I do this one. Use the identity here: a square minus b square, that is a plus b, a minus b. And what is common in these two? 2a is common. The pending part is x minus b. Now again, what is common in this whole thing? X minus b is common. What is left here? X plus b. And what is left here? 2a. That's it. So the final answer is x minus b, x plus b plus 2 times c. What was the question? Factorize. Factorize means this whole thing should be equal to product of two expression, algebraic expression. That's it. Second part. Second part, we have factorize this whole thing. Okay, so how can I factorize this? What I'm gonna do, this kind of question is already done, but it's okay, I'm taking this again. I'm going to assume x square plus x as something else, suppose y. So the whole expression become y square plus 4y minus 12. Now we know how to factorize this. Here sum should be 4 and the product should be minus 12. So two numbers are positive 6 and minus 2. Sum of these two is 4 and the product is minus 12. So how do we factorize y square plus 4y minus 12? In these two way, I'm doing in short. One factor will be this one and second will be minus 2, I guess. Correct. This is not my final answer because y was my assumption. So replace y by x square plus x plus 6, and here is x square plus x minus 2. Now we have to factorize this further if it is possible. So in this case, sum should be 1 and product should be 6. Sum should be 1 and the product should be 6. Are there two such number whose sum should be 1 and product should be 6? No, it's not possible. So I cannot factorize this factor. Keep it as it is: x square plus x plus 6. In this case, sum should be 1 and product should be minus 2. You can do this part separately. Okay. Sum should be 1 and product should be minus 2 in this case. So two numbers are minus 2 plus 1, minus 2 plus 1, x square minus 2x plus x minus 2. So if I factor this, I will be getting two factor. One will be x minus 2 and next will be x plus 1. So if I factor this, I will be getting two factor: x minus 2, x plus 1. That's it. This value is nothing but x square plus x whole square plus 4 times x square plus x plus 12. Means this whole thing equal to that thing, and I just factor this. So whole polynomial is factorized here. Something into something into something. Let's pick the part number 3rd. It's a little tricky, so without practice you won't solve such a problem, such kind of problem. X square or 1 over x square positive 2 minus 2x minus 2 over x. So what is the method to solve this question? Okay, I'm writing again here so that you won't get confused. This is 2. Can I write this 2 as x times 1 over x? Because this get cancelled, I'll get 1 here. 1 times 2 is 2 only. And I'm taking common from here 2. The pending one is this value. This is identity. Which identity I'm using here? A square plus 1 over x whole square. Or you can do one thing here. Don't adhere to write whole square here. I'm skipping one step here. This 1 over x whole squared is nothing but this value. Now a square plus b square plus 2 times ab is a plus b whole square minus 2 times x plus 1 over x. What is common in this and this term? X plus 1 over x is common. What is left here? 1 time x plus 1 upon x is left. What is left here? Minus 2. That's it, my answer. So this whole thing is equal to x plus 1 over x times this value. There's no need to take LCM. If you want to take LCM, you can. Otherwise, just you can keep as it is and you'll get the full marks. Let's see what is next question. If p equal to if p equal to 2 minus a, then we have to prove aq plus 6 times ap equal to 0. Let's see. There are again many methods. One method is direct method. What is that method? Just substitute the value of p here and here and then simplify. You'll get the answer. But that is a little longer method, a complicated method. Easy method is there. What is that easy method? Take these two terms on the left hand side. So I will be getting this value. Can I write the left hand side in this way? Because minus 2 plus I'll get minus 2 here. One identity we know. What is that? If a plus b plus c equal to 0, then sum of their cubes will be equal to 3 times of their product, 3 times ABC. Now assume this is A plus this is B plus this is C. Now because A plus B plus C equal to 0, then what I can say? I can say AQ, BQ plus CQ will be equal to 3 times A times B times C. Let's simplify. PQ, this is AQ, this value is minus 8, this is 3 times minus 2, minus 6, AP. Now take this value on left hand side, that get changed here, negative become positive, positive become negative. Take this value on that side. This is our proof. You can check it. This value is nothing but the given value. You can rearrange the terms as per the given question. 6AP plus p times q minus 8 equal to 0. Hence proved. Next question. It seems to be a little weird, very longer one, very complicated, but it is not. Prove that this left hand side is equal to 1. Let's see how to solve this question. I'm choosing left hand side here. Left hand side. I'm doing direct. This value can be written as 0.75 whole cube plus this is again whole cube divided by whole squared minus, okay, write this as it is, positive 0.25 whole square. This is left hand side. Now AQ plus BQ, what is that? Sorry, identity. AQ plus BQ is equal to A plus B, A square, negative AB, B square. So uses this identity here, AQ plus BQ, that will be equal to A plus b a square minus ab minus ab plus b squared whole divided by, write this value as it is. No don't calculation. Don't calculate this one, because if you calculate this one, the question, the answer will get more complicated. So the best way, just keep as it is. Let's see what happens. This whole thing and this whole thing both are same, so get cancelled. What is remaining? 0.75 plus 0.25, that is nothing but 1.00, means the answer is 1. That's my answer. I hope you understood this one. If you have mistake, sorry, if you have any complications or any problem, do let me know in the comment box. Next question. If x plus 1 over x equal to 5, then I am to find the value of x power 6 plus 1 over x power 6. So there are two methods made here to solve this question. First method is, first take squaring on both sides, and then take, after a few steps you will be getting something, and then cubing on both sides. Take cube on both sides. Or what you can do else, first take cubing on both sides, means take cube on both sides and then take square on both sides. That's up to you. I am choosing this way. So first squaring on both sides, x plus 1 over x whole square. I just took square on both sides. A plus b whole square, a square plus b square plus 2 times ab equal to 25. This got cancelled, only 2 is left here. Bring this on the right hand side. So x square plus 1 over x square equal to 23. Next, cubic on both sides. If you take cube on both sides, what will happen? X square plus 1 over x square whole cube equal to 23 whole cube. Now again the formula. What is the formula? A plus b whole cube, that is equal to, okay, I am writing this formula here. A plus b whole cube equal to a cube plus b cube plus 3 times a plus b, or you can directly use this formula, a cube plus b cube plus, okay, this will be better in this case, no need of this one. So let's see what will happen in this case. What is the cube of this one? What is the cube of this value? 1 over x6 plus 3 times a b a plus b here is equal to 23 whole cube. Okay, right, as it is, I'll solve it later. Now this got cancelled. This value is x power 6 plus 3 times, what is this value here? This value is 23. This value is 23 here. So 23 equal to 23 whole cube. Now come here. We are left with x6 plus 1 over x6 equal to 23 whole cube minus 3 times 23, that is 69. Now simplify, you'll get your answer. What is 23 3 times? 23 3 times will be 12167 minus 69. So the answer is 12098. That's the final answer. That is the final answer, and my suggestion for everyone, keep every important step in here rectangular form. That will show, that will highlight your points, your steps. Let's pick the next question here. Simplify this whole expression. So again, I have to use the identity. And what was that identity? If a plus b plus c equal to 0, then what we can say, a cube plus b cube plus c cube, that will be equal to 3 times abc. If I assume this whole thing is a, this whole thing is b, this whole thing is c, then what will be the sum of these three? You can check it. Okay, I'm doing here in a little short way. This is a, this I'm assuming b, and this I'm also assuming c. So let's see what is the sum of all. What is sum of all? 0. It means what I can write the numerator, I can write the numerator as 3 times a. What is a here? This is a. What is b? And what is c here? This one. So this numerator in the given question can be written in this way. Why? Because I proved a plus b plus c is equal to 0. Same in the denominator. If I assume this bracket part a minus b as a, this is a, this is b, and that is c. Let's see what is the sum of these all. This is a, this is b, and this is c. So if I sum them up, I will get here 0. It means the denominator part can be written 3 times a, b, and c. This again get cancelled. Now in the numerator, a square minus b square, the identity a plus b, a minus b. Same with the another one, b plus c, b minus c. And the next one, c plus a and c minus a. In the denominator, we have a minus b, b minus c, and c minus a. A minus b got cancelled, b minus c got cancelled, c minus a got cancelled. So the final answer is here. That is your final answer, my dear. What was the question? Question was simplify this whole thing. I used the identity to get my final answer. That's it, my dear students. So this was the last video of chapter polynomials. I hope everything will be understood clearly. You can see all these videos again and again. In case you have doubt, just let me know. I'll try my best to elaborate everything in more precise way. So thank you.